But for now, if we don't have a particular problem that we want to look at, then I may just do, here's what I'll do. Okay, I'm going to go through kind of in detail. I'm going to go through number 1. I'm going to go through number 3 in more detail. And then I'm going to give you some kind of hints as to where to start on number 5 and number 6. I won't go through the whole thing, but I'll spend a quick minute getting you started on it, and then we'll talk about number 7. All right, that's going to be our plan. Number 1. So remember that our surface area formula, I always start by writing out the surface area and volume formulas that we're going to use. Surface area for a cylinder is, we're going to use the same as our prism formula, since the cylinder's got 2 bases. It's got the circle down here and the circle up here. So that's going to be twice the area of the base plus perimeter times the height, but perimeter for a circle is called circumference. Circumference times our height. And then our volume is area of the base times height. All right, so we'll start with our area of the base. I've been putting that in yellow as we've done these problems. Area of the base is going to be, well, area of a circle is pi r squared. It'll really help you to know these area and circumference formulas. I would say if you know no other formulas from this chapter, make it that you know area of a circle, circumference of a circle. Area is pi r squared, circumference is 2 pi r. Because our next chapter, our last chapter of the year, is going to be all about circles. And we're going to use those formulas for area and circumference in that chapter. So just make sure you know those formulas. Pi r squared, our radius is 5. So that's 25 pi. So that's our base area is 25 pi. Then our lateral area is always this second piece of the surface area formula. It's just a way to split up the formula so that we don't have to do it all at once. Circumference times the height. Circumference is 2 pi r. 2 pi times our radius. And so that's going to be 2 pi times our radius is 5. So that's going to be 10 pi. Height is the distance that connects the 2 bases. So that's right here. Connects the bottom circle to the top circle, that's 8. So what I'm most interested in when we're looking at these problems is to know that we can put the pieces together that I give you, and that we can identify, where's the radius and where's the height, and what's the difference between height and slant height when we get to pyramids, and which type of shape is this? Well, you should know that this is a cylinder, for example. And so since we're doing cylinders, we should use the formula for prisms. Those are the kind of things that I'm asking you to know. The plugging in numbers itself is not all that hard. (10 pi) times 8 is 80 pi. So that is this part of the formula. So when we go down here, 80 pi is going to go over here in the second part of the formula. Then plus twice the area of the base. 2 times area of the base. Area of the base is 25 pi. So we've got 2 times 25 is 50. So 50 plus 80 is 130 pi units squared. And then our volume is just area of the base times the height. So we're going to multiply those together. Area of the base, well, area of the base is up here. It's 25 pi. Right, at this point, it's just putting our pieces together and plugging in the numbers. And then our height is 8. So volume is going to equal, let's see, 8 quarters. So if I have 8 quarters and I have $2, 200 pi. And that's units cubed for volume. Units cubed for volume. That's number 1. I'm not going to go through number 2 because it's just a matter of plugging your numbers into the formula. Make sure you find and look up in your notes the formula for surface area and volume of a sphere, because number 2 is a sphere. And then you should be set to go. So I'm going to go on, because if you're not finished writing down, you can just rewind a second and pause. And let's look at number 3. Number 3, I'm going to go through in a little bit less detail. I'm going to focus on finding the volume. Or actually, let's focus on lateral area. Okay, because base area is the same formula. It's still pi r squared. But let's look at lateral area. Lateral area, in this case, since we have a cone this time, lateral area is going to be the circumference times our slant height. And the slant height, remember I've talked about 2 different heights. I have my, I can talk about the height where I'm looking straight up at the top of our pyramid or our cone. So I'm dead center and I'm looking straight up. That's my height. Here's h, it's 15. That's going to go in the volume formula. But my slant height is scaling up the side of the cone. So, if I were climbing up the side of this, that would be my slant height. It's called a slant height because it's on a slant. So that's our slant height, and we actually don't know our slant height. And so that's going to take doing Pythagorean Theorem to figure out. So let me just draw the triangle again down here. Here's our height. This one's our height. It's 15. Here is our radius, distance from the center out. It's 8. And then here's my slant height. So this is where Pythagorean Theorem comes in. You're going to do slant height squared, that's the hypotenuse, side opposite the right angle, equals 8 squared plus 15 squared. Boom, boom. And that will give you your slant height to plug in here. You should get a nice whole number here. You shouldn't get a decimal. But then when you go to do volume, volume for a cone is 1/3 area of the base times the height. And height, here's where 15 goes. Oh, one quick correction. Lateral area formula's got a 1/2 for the cone. And same when you do the surface area formula. Surface area for the cone is going to be area of the base plus, and then this piece here, plus this lateral area. So these two numbers that you get in your answer, just add them together. That'll give you your surface area. But you're using a different height when you go over to do volume. You're using the straight up and down height. And just a reminder, if you want to check your work, or if you have a question on a particular problem, then feel free to take a picture of what you have so far and send it out to me. And I'll get back to you with some feedback of, if you're stuck, what you're missing, or if you just send me your final answer, I can tell you if you're doing it right. If you're not sure, if you want that kind of feedback on these problems, then I'm happy to do that. Most of these problems would be if we were in class giving a test. This would be the review I would give out right before the test. That's where most of these problems come from. All right. Moving on. So 1 we did. 2, you just need to look up your formulas. They're not that hard. 3, we looked at a little bit. We're going to... Oh, well. 4 doesn't exist, apparently. All right. Messed up my numbering. Let me fix that so that when I go to reconvert the file. This is 4. This is 5. And this is 6. 6. There we go. Saving that. Okay. Square base. So I'm not going to go through the area. You should know which height this is, though. This is my slant height, because it's scaling up the side of the pyramid. This is a square pyramid. All right, and so that means that I actually need to solve for my height. Right, this would be my height if I'm standing dead center of the pyramid, looking straight up to the top. That's height. So the triangle that you want to draw is this triangle. Okay, it's the height that's dropped down from the top, my slant height here, and then my distance from that center of the base out to where the slant height is. That's my right triangle. So I'm going to redraw that over here. This is 13. This is the height we're trying to solve for. And then we should know what this is, because this side is 24. That means this is also 24. This entire side. And so how far am I going in my square? Well, I'm going halfway across. Yeah, because I'm going from the edge here out to the middle. So that means I'm going halfway across. So halfway across will mean it's half the distance, 12. Here's 12. And this time I know my hypotenuse across from the right angle. I know my hypotenuse. So when I do Pythagorean Theorem, I'm going to do 13 squared equals 12 squared plus h squared. This height, this leg over here is what I don't know. And so now, again, I should get a nice whole number here. You should not get a decimal if you're doing it right. Okay? So that's my hint to start you on that problem. Now, the rest of this you should be able to do without the Pythagorean theorem. It's only when you get to volume, because volume is 1/3 area of the base times your height. That's when you get your, that's when you need that height. You're going to use the 13 when you do surface area. And then for perimeter, you're going to add up your sides. There we go. All right, hint on number 5. The tricky part of number 5 is area of the base. So we'll start that. And the reason the area of the base is tricky is because it's a regular octagon. This is an octagonal prism. So that's what this looks like. Here's my two bases. Here's my octagon over here. Here's my octagon in the back. So I got an octagon in the front, octagon in the back, and then I've got these segments that connect the front and the back. So this is my height. That's my height of the prism. So when we go over here and we start doing height, 32 is my height. But right now I'm just interested in the area of the base. And since the base is an octagon, then that means that we're going to use 1/2 ASN. That was our formula for regular polygons. So that means we need what's A, what's S, what's N. Well, I was nice. Normally on this problem, I decided to make it a little bit easier. Normally on this problem, I'd ask you to solve for the apothem, but instead I just gave it to you. I gave it to you, I rounded it off. A is about 7.24, so let's use that. And then our side length, S is our side length, is going to be 6. That's right over here. Here's that side length, is 6. And then N is our number of sides. So since we have an octagon, we know it's an octagon, so that means it's got 8 sides. So area of the base will just be 1/2 the apothem, which is 7.24, times your side length, which is 6, times your number of sides, which is 8. Okay, then you're going to do perimeter of the base times the height. Perimeter, we just add up all the sides. And so all the sides are 6, so we add that up 8 times. 6 plus 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 6. And that's our perimeter. Now, here's what I think is the more interesting type of question. Because I've talked a little bit about these kind of problems and what each of these types of questions mean. So for each scenario, tell whether you would use perimeter, area, surface area, or volume. Now remember, these are for 2D shapes, and surface area and volume are for 3D shapes. So first thing you want to think about is, do we have a 2-dimensional shape or a 3-dimensional shape that we're interested in? And then perimeter is our border around. Area is how much space are we covering. Surface area is how much do we need to wrap around the entire shape? How much material do we need to make this shape? And then volume is filling the shape. How much space does the shape take up? So instead of giving you a bunch of word problems where I'm, just loading you with a bunch of, diagrams or, bringing in a bunch of numbers and having you use the formulas, I just want you to understand which situation goes with what. So let's look at that. I'm going to do probably the first 3 and then see what you want to do with the last 3. All right. You're setting the table for Thanksgiving dinner and need to know how much room you'll have on the table. So since we're looking at a table, all right, here's a table from above, okay, because we're looking at the table itself. That's a 2-dimensional shape, right? Because we're not interested in like the legs of the table and that kind of stuff. Not if we're setting the table. But I'll draw them. Just show my masterful drawing skills. But we're only interested in the top of the table. Okay, so first off, this is a 2-dimensional shape. And so next we need to ask, are we just interested in the border along the outside? Or are we interested in the space that's on the table? And how much room we have on the table? Oh, how much room we'll have on the table? That's what we're interested in. So we're interested in how much room we have here on this table. So that's an area question. And that's all you need to do on these problems. It's asking for, here's the context of the problem, and I'm asking which type of formula is going to help us answer that question. Let's look at part C. You've just made the world's largest block of Jell-O. I mean, we're all spending our spare time different ways these days. So maybe that's what you've done with your time. And you want to know how much you've made. So if you want to know how much you've made, then first off, since it's a block of Jell-O, then that is a 3D shape. Okay. And so here is my block. It's not all that large, but that's okay. There's my block. And I want to know how much Jell-O this is. Okay, so I'm not just interested in going along the outside of the shape. I want to know how much space this entire block takes up. This is a volume question. All right, we'll do one more and then we'll call it good. Then we'll be done. You are in charge of making a new design for DHS water bottles and want to know how much space you have on the bottle. Again, if you missed it at the start, just so you know, I've been talking about kind of ways that I can reward and give a pat on the back to the people that have been coming to these sessions and keeping up with the work and dedicating their time to keep up with their education, because I think it's important. I know the school is doing an exam exemption already, but just some way that I can either, recognize those people or do something or give something to those people. So if you have ideas, let me know. All right, last problem. If you're making a new design for DHS water bottles, well, a water bottle, oh boy, I have to draw more. All right, here's a water bottle. Okay. Very, very thin bottle. Very tall bottle. All right. So this is a three-dimensional shape. And what we want to know is how much space you have on the bottle. Okay, so this isn't in the bottle. This isn't on the inside of the bottle. We're not trying to fill this bottle. That would be a volume question. We're trying to work along the outside space of the bottle to make a design for this bottle. All right? So this is a question about how much material you're going to have to work with. So that is talking about how much area you've got along the outside of this figure or on the surface of it. So that is a surface area question. That's a surface area question because it's asking how much area takes up the outside or the surface of the shape. Remember, the way I've been talking about it is perimeters fencing or bordering, areas carpeting, a two-dimensional space. I always talk about surface areas like packaging or labeling, and then volume is filling, or how much space does it take up. So that's what these questions are asking. All right, and I'll work on getting the files working, and I'll look into that shortly. Hopefully within the next hour, you should see something go up on Canvas that has the file fixed. I'll send something out over my mind when that's working again. And oh, by the way, one more thing to let you know is if you haven't been checking Canvas, one of the new things, that's my stream. One of the new things that I've been putting up there is on my calendar, on top of the assignments that I've usually been posting, I've also been posting a calendar of when I'm having these meetings and what time, so that you guys know when these things are happening. I usually post and update these things at the beginning of the week. So if you ever want to know when these things are happening, then sometime like Monday afternoon or evening, check Canvas and check the calendar, because you'll see that this worksheet is due on Friday, and there's the file for it, which I'll fix. And then you'll see that I posted that at 1:30 today, I would be live, and that this would be a review session, and that we would look at some of these questions, and here's the link to the stream that you're watching right now. So I've been sending those out of a remind. I've been putting them in the announcements, but this calendar is another place for you to be able to check those things and to know that these things are going on. So I've been trying to communicate as best I can when these things are happening, so that you can be here and plan around it in advance. All right, but thank you guys so much for coming and for keeping up with the work. I really do appreciate it. And I will talk to you guys more soon. Let me know if you have any other questions.